Hey everybody, I hope you're doing well. In this video, I want to talk about how to compute the area between the x-axis and the curve. And we'll start off with a curve above the x-axis, or at least not below the x-axis. So I'm going to consider y equals x squared to start off with. Now in this particular curve, I can choose any 2 points that I want to figure out the area between. So for instance, let's choose -1 and 2. This is not going to be to scale. So I want to compute specifically, I want to compute this area right here. The area between y equals x squared and the x-axis. Now to do that, here's a basic outline of how this goes. So I'm going to draw a much larger picture. I want to go from here, x equals -1, to here, x equals 2. Here's the construction of my integrand. I'm going to arbitrarily draw a rectangle. And yes, this looks like a little line, but this is going to be a very, very thin rectangle. I'm going to have a top and a bottom to this. So the height of this rectangle, the height of this, is just going to be given by x squared. But the width of it, that's what I'm going to call dx. That's our integration stuff, dx. So the area of this thing, the area, is going to be the integral from -1 to 2 of the height times the width. And remember, integrals, they're Riemann sums. So this is really an area. Now, the fundamental theorem of calculus, part 1, is not applicable here because I'm not taking derivatives. So, fundamental theorem of calculus, part 2, and I want you to get used to knowing which one of those you're using. Part 2 says, how do we evaluate a definite integral using antiderivatives? So in this particular problem, an antiderivative is x cubed over 3. And I want to evaluate this between 1 and 2. So doing that, I get 8 over 3 minus -1 cubed over 3. -1 cubed is -1. So I wind up getting 9/3, or just 3. So this area is 3. And there's an area of a function between the curve and the x-axis. Now what about something a little bit more complicated? What about something like, oh, let's do a trig function. Let's do y equals sine of x. And I want to look on the closed interval from 0 to 2 pi. Well, what does that look like? Well, a sine curve looks like this, where this is pi and this is 2 pi. Now, if I blindly do this rectangle that goes from top to bottom, and I forget that it actually changes when I go to that region, I get something that's not quite right. So this is the wrong way to do this. It's the integral from 0 to 2 pi of sine of x. This is, again, the wrong way to do this. An antiderivative of sine is negative cosine. I'm going to evaluate this between 0 and 2 pi. So what do I wind up getting out of this? Well, I get negative cosine of 2 pi minus negative cosine of 0. Well, cosine of 2 pi is 1, so there's -1. Cosine of 0 is 1. This is +1, and I wind up getting 0. But this curve right here, This isn't 0. So the idea is to break these up into two regions. So region number 1 goes from 0 to pi, and that is sine of x dx. Because I go from here to here, and this is above the x-axis, so I'm going to leave this as positive. I evaluate this, I get negative cosine of x from 0 to pi, and I wind up getting 2 out of this. I'm going to leave that arithmetic trigonometry calculation to you. Region 2, I'm going to go from pi to 2 pi. And instead of looking at sine of x, well, now my curve is below the x-axis. So I know I'm in the negative area. And I wind up getting cosine of x. I evaluated between pi and 2 pi. And here, I get an area of 2. So my total area is 4. I add those together. In a later video, we'll talk a little bit more about the area between two different curves. And in fact, I can consider this particular problem the area between two curves, y equals sine of x, and the other curve is actually y equals 0. And the idea here is always top minus bottom. That's always going to be positive. Top is always a larger number than a bottom. So there are two examples of the area underneath a curve, or between the curve and the x-axis. I really shouldn't say under, because sometimes it's over, like in this region right here. I hope that video was helpful. If you have any questions, let me know. Have a great day. Bye.